Hi, my name is Oisin, and this is my project, Quantum Chemistry in Scala and Spark. During this presentation, I'll give an overview as to why we chose Spark, the Hatree-Foch methods that we chose to implement, our Scala implementation, our Spark prototype, and what further work is needed. So, why did we choose Spark for this project? The main advantage of Spark is the RDD, the Resilient Distributed Dataset. It is lazily evaluated, meaning that transformation operations on an RDD are not performed until an action is called. This means Spark can optimize the best route for a job and does not need to dump large amounts of data to disk in between operations. It is fault tolerant as each RDD has a record of the operations performed on it, and these can be recomputed by any partition should it fail. In practice, it is 10 to 100 times faster than Hadoop MapReduce and allows for much more concise code. The Hatree-Foch method is a simple quantum chemistry method allowing for the approximation of the wave function and energy of a many-body system. It is the basis of molecular orbital theory, an iterative algorithm, and has a very large electron overlap integral which scales as n squared relative to its basis set. As this can add up quickly to gigabytes of data, it makes it an ideal candidate for our project. Our initial Scala prototype was built with inspiration from the Libint library. We utilized Breeze, a numerical library in Scala and Spark. This Libint prototype utilized the eightfold symmetry in the integral in the second half of this expression, which is key to evaluating the new Foch matrix on each iteration of the algorithm. This works for small text files. However, it was still too object-oriented and needed more coarse transformations such as map and flat map. Next, we proceeded to the Spark prototype, where first we needed to convert the 4D integral dataset from binary files to HDFS, structured as ij and then the list of values. We could then call this HDFS text file as an RDD and perform the necessary transformations to extract the index and value required to update the Foch matrix. Finally, a collect call was added to evaluate the RDD so that it could be added to the Foch matrix. Each Spark job consists of a DAG, directed acyclical graph such as this. The collect action causes the dataset to be initialized as an RDD, and then the appropriate transformations are performed as seen in the code below. Spark then passes these DAG jobs to the appropriate worker. There are still some remaining issues with the prototype. It still only works for small datasets, and we have not been able to get it to scale for large datasets. We suspect that the code is not correctly handling the multiple HDFS partitions which are created when the file was mapped from binary. Also, the calculations for higher angular momentum functions, for example d orbitals, are incorrect when compared with the standard libraries. Some possible solutions to this are to check the partition structure and create better unions of multiple RDDs, to read the binary files instead to parquet files, which store the data as double rather than strings. We also need to review and debug the Libint style fnew calculation component, as this is failing for high angular momentum functions. In conclusion, we developed a Scala brief prototype for the Hatree-Foch method, then adapted this to Spark for small basis sets such as H2O. However, it needs further adjustment to run on large scale. Thanks for watching, and goodbye.